Hi, welcome to Solving Quadratic Equations. Now, we went a little bit out of order. We had to make sure you could factor a quadratic equation. And that is very, very, very important because we're still going to be factoring in this class period and in this video and for a very long time to come. But you know some things about parabolas, like you know the vertex, you know the axis of symmetry, you know, I don't know, the max, the min, stuff like that. What you don't know yet is how to solve a quadratic equation, and that's always the question, right? How do you solve something like this? What is it going to be used for? Well, today we're going to solve quadratic equations. In a little bit, we're going to talk about what it's useful for. So, the standard form of quadratic equation in one variable, that just means just x, is ax squared plus bx plus c equals 0. Okay, and that's written in that blank, where a, b, and c are all real numbers and a does not equal 0. And you've seen this definition of standard form before. A root of an equation is a solution of the equation. What that basically means is that we solve for x in whichever way we can. Now, there's 3 methods for solving a quadratic equation so far. The first is by graphing. Okay, it's basically in a graph, and this works for any quadratic, okay? Any quadratic that you have is going to be a parabola. Well, the solution to the parabola, to the quadratic equation, is where your graph crosses the x-intercept, or the x-axis. So you're finding the x-intercepts by graphing the standard form, just putting it in your calculator. You can also solve it by using square roots, so write the equation and solve. And I'm going to show you how to do that. Or you can solve by factoring. So, let's look at this graph for example 1. We have this graph, it's on here already. If you don't remember how to graph by hand, that's perfectly fine. We're not asking you to necessarily, as long as you have some good points. Remember, 3 points always. But you can always put this in a calculator, you can put it on Desmos.com. Whatever you have at home works. But where does it cross the x-axis? Well, this is the x-axis, which means that our parabola crosses here and here. So here, x equals -5, and here x equals 2. We're always worried about x. Our y here is always 0, so that's why it doesn't matter what y is now. We always want to find x. That's what's changing here. So x is -5, x is 2. That's the answer. That's it. Let's try it again. What about for this parabola? Well, the x-axis is down here. It only crosses once. It crosses where x equals 3. Right there. So x equals 3 is our answer. You don't always have to have 2 answers. You can have 1. Or you can have 0 answers. That works too. That's always a possibility. You can have 2, 1, or 0. We're going to get it more into how you can determine this later on. But just by looking at it, it only crosses once, so there's only one answer. Now, if we go back here, when do we use this? When can we graph? You can graph all the time. All the time. You can be a very visual person and you can look at the graph and you can see, how many solutions do I have? How many times does it cross the x-axis? What are those numbers? And if it's an easy number to find, that's what you can do. Now, if I specifically ask you to solve using square roots or solve by factoring, I expect to see the work, but if you want to put it into your calculator later and check, you're welcome to, always. Now, after you've looked at the picture, we're going to potentially solve using square roots, depending on what that answer is. And it might not be pretty, right? It might not be a whole number. So if it's not a whole number, we can see if we can solve using square roots. Now, when do we use this? And I'd like to address that first. Our standard form is, remember, let's go back, ax squared plus bx plus c equals 0. This bx, if that is not there, that's when you solve using square roots. So I'm going to put that here. There is no bx term. So if there's not a middle term, if there's no x with a number out front, that's when you're going to use solving using square roots. So if you look at this example 3, we have 2x squared plus 14 equals 70. There's no bx. Okay, there's no x with a number out front. So we're just going to solve for x the way that we know how. Well, first, we need to get the 14 to the other side. So we have 2x squared equals 56. Now, x is still not by itself yet, so we need to get rid of that 2. So we get x squared equal to 28. Now, remember, the opposite of a square is a square root. If you didn't know that, make sure you know that. The way to get rid of a square is by taking the square root. So you take the square root of both sides. Now, here's an important rule. When you take the square root, we have a positive answer and a negative answer. That is what the plus minus symbol means. It means there's a positive version and a negative version. So we don't just have the square root of 28, we have plus or minus the square root of 28. This is huge. Okay? This plus or minus is very, very, very important. Make sure you know that. Do not leave it out. If you take a square root, do not leave out the plus or minus. If it's already done, that's a different story completely. If you are taking a square root, you do a plus or minus. Now, the square root of 28, it might have been a while, but we need to come over here and simplify it. Because 28 is divisible, it's the smallest thing it's divisible by, 2 to get 14, that's divisible by 2 to get 7. So we have a pair. Remember, when you have a pair, you can take it out. So we actually have plus or minus 2, and then the 7 is left over. Now you can also write this answer as x equal to 2 root 7 and x equal to negative 2 root 7. That's what it means to be plus and minus. That means you have the positive version, that's one of your answers, and then the negative version, like you see here, that's the other answer. You have to have 2 possibilities though, because we don't know which one it's going to be. Okay, we have no idea, so we have to consider both. Alright, let's try that one more time. Actually, 2 more times, right? Example 4. Solve 4x squared plus 20 equals 16 using square roots. Well, the reason we're using square roots is partly because they tell us to, and partly because there's no bx term. Bx. Right? There's no middle term in there, so we can just solve for x the way that we know how to do. So the first thing we need to do is subtract 20. 4x squared equals negative 4. Alright, well x squared is still not by itself, so we need to divide by 4. So that x squared equals negative 1. Now again, remember, you get rid of a square by taking the square root. Okay, that's what you do. That is simply the process. They are inverses of each other, so they cancel. So we have x equal to plus or minus the square root of negative 1. Now we have a definition for the square root of negative 1. Remember, that is something that we can circle and take out. The square root of negative 1 is I. So our answer is just I. It is also a negative I. You can write it like this, or you can write it like this. Whichever one works best for you, whichever one makes the most sense to you, is fine as long as you have the positive version and the negative version. You have to have both. If you're missing one, it is wrong, but either way to write that works. Okay, so this next one is a little bit complicated, and it's not because there's a fraction. Okay, fractions are actually relatively easy to get rid of, and because I need a little bit more space, I'm going to write it again. Remember, to get rid of a fraction, you simply multiply by the reciprocal. So we have times 4 over 3. See, that wasn't so bad. Okay, so now, because that plus 1 is inside, you have to do the exponent first. Remember, please excuse my dear Aunt Sally, right? Parentheses, exponents, blah, 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 blah. We have to get rid of that exponent first before you do what's inside the parentheses. So we need to square root. So we have x plus 1 left over because the square went away. Not what was inside, just the square. And we have plus or minus the square root of 40 over 3. And I'm going to come over to the side, and we are going to simplify that radical. Right? We have the square root of 40 over the square root of 3, because remember, when you have a square root over in a fraction, you can do the square root of the top over the square root of the bottom. Works perfectly. Then we need to simplify that 40. So we have 40 divided by 2 is 20. Well, that's divisible by 2, you get 10. That's divisible by 2, you get 5. So we have one pair, and 5 times 2 is left over. So we take out the pair, and you leave a 2 times a 5. Well, what's 2 times 5? 10. So we have 10 over the square root of 3. But we have a problem because we are not allowed to have square roots in the denominator, which means that we multiply the top and the bottom by the square root of 3. This is all just a refresher. We get 2 square root of 30. That is a pair, so we can take it out, and we're left with 3. Now, if you go and you try to divide 30 by something and see if there's a perfect square in there, there's not. So we're going to come back over here to our problem and say that x plus 1 equals plus or minus, always, 2 square root of 30 over 3. Now we still need to solve for x. The x is actually not by itself yet. There's a 1. Because it's added, we subtract. So we get x equal to negative 1 plus or minus 2 square root of 30 over 3. Now again, there's 2 ways that you can write this. You can leave it as is, or if you'd like to write both possibilities out, we have negative 1 plus 2 square root of 30 over 3, and x equal to negative 1 minus 2 square roots of 30 over 3. And those are your answers. So it's not too bad, right? We're only adding that you are now solving for x. You already knew how to simplify radicals. You already knew how to find I. All you now have to add is solving for x. So, you remember factoring? I hope so. If not, you might want to go back and re-watch those videos over factoring, because the process is not changing. It is simply adding a step at the end, so you still have to know how to factor. If you don't know how to factor, go watch it again. Okay? So, the zero product property. Well, we'll get into that in a second. The first thing we need to do is solve by factoring. Well, we need to factor. And we have a problem with example 6, and that is that it is not in standard form. Remember that standard form is where ax squared plus bx plus c equals 0. Okay, so if it doesn't equal 0, you have to make it equal 0. So we actually, before we begin, need to subtract 48 from both sides, because that is the fastest way to get 0 on one side. Now we factor. Remember, we have a times c. That goes on top, so we have negative 48. The middle term goes on the bottom. What are factors of negative 48 that add to 2? Well, you can make a list. I did. And we got 8x and negative 6x. Remember, you start at x squared. You go down to 8x, over to negative 6x, up to negative 48, and from here we group the first two and the last two. What can come out of the first two? An x, we get x plus 8, The second two both have a negative 6, and that gives us x plus 8. Remember that they have to match. They have to match. These two numbers have to match. Because remember, these two numbers, those two terms make our first factor, and then the x and the negative 6, that's what makes the second one. Now originally it equals 0, so we're going to keep making it equal to 0. Then, this is the solving part, right? Nothing there has changed. Everything there is a review. The new part is that you take the factors, so the x plus 8 equals, and set it equal to 0. So you have x plus 8 equals 0, and we also have x minus 6 equals 0. And those are pretty simple problems to solve for x, right? We can subtract 8 from both sides to get that x equals negative 8. And over on the blue side, we can add 6 to get that x equals 6. And there you go. Those are your answers. 1, 2. Done. Which means that if you were to look at a graph, they would cross the x-axis at 6 and negative 8. That's all that means. So let's do one more for good measure. This is the last example I'll do. Again, we have a times c. Now this one, I'm going to say that f of x equals 0. So that's going to be equal to 0. It'll be okay. 4 times 3 is 12. So we put 12 on top and a negative 13 at the bottom. Factors of 12 that add to negative 13 are negative 1x and negative 12x. Remember, you can make a table if you need. We start with 4x squared, go down to negative x, over to negative 12x, and up to 3. We group first two, last two. In 4x squared minus x, the only thing we can take out is an x, so we're left with 4x minus 1. And in the right two, remember what I said, if it starts with a negative, you have to take out a negative. And because this negative 12 is negative 12, we take out a negative 3. And then we're left with 4x minus 1, which is exactly what we anticipate. Then, whatever's inside, that makes one factor. Whatever is outside, that makes the other. We say that that equals 0, then we come over to the side and we solve each one set equal to 0. So we get x minus 3 equals 0. Add 3 to both sides. We get 3. 4x minus 1. Well, this has one added step, but you're doing the same thing, right? We have to get x by itself, the 1's in the way, we add it. 4x equals 1. X is still not by itself, we need to divide by 4. So x equals 1 over 4. So if you were looking at a graph and doing this, it would give you that fraction, so you wouldn't just look at the graph to find the answer. You would have to go in and solve by factoring or using square roots. Since this has a bx, you have to solve by factoring. And that is it. That's the video. Your two answers here are 1 over 4 and 3. Have a nice day.